Hey, what's up? So today I thought I'd talk about render settings. I thought I'd get the boring stuff out of the way first before we can get into the really interesting tutorials, because I think there are a lot of misconceptions about cycles and Blender in general when it comes to rendering. I've never seen a proper tutorial about this online, so I thought I'd share my experience with this render engine because I generally think it's one of the best ones out there. I found a few settings that worked on every single animated scene that I had to render, and they are really useful to know. So I just thought I'd get into that today. First of all, you should just copy the settings that I'm giving you right now on the screen that I'm showing. If you copy these one-to-one, they will work on 99.9% of the scenes that you have. I'm going to show you what to turn on and what to increase depending on the situation specifically, but in most situations these settings are enough. This is exactly what I used in my short film in pretty much every scene, and also in all my other animations as well. So if you take anything away from this tutorial, just copy those settings. But now I'm gonna show you specifically what they do and what to increase in very specific situations. The first thing I'd like to talk about is sampling. So the noise threshold is one of the most misunderstood settings in Blender. So I prepared a very quick test scene just to show you the power of noise threshold. So the number of samples, the max samples, are the budget that Cycles has throughout the entire render time, and once it hits a certain amount of noise in a certain area of the image, it will stop using the extra samples. So you can technically have this number as high as you want, although not too high because it takes just a few seconds extra to catch up to the final max sample number. But if you keep it at something like 2048, it's gonna be perfect for even the most complex situations where light is bouncing in very strange ways. For example, I created this example specifically to show you the problem with path tracing in general, because when you have very challenging situations where the light is bouncing in very complex ways, for example, inside of this VDB, there's a point light, and the samples don't have a direct and easy way to resolve the noise of the image, and that's why we're getting all these fireflies on top of the deer. That's why we're having all this noise right on the source of the light, though, not around the entire volume, which is the entire problem that the noise threshold setting is going to solve. So basically, let me show you what happens when you render this scene, for example, with 128 samples. If you re-render that scene with the setting that I showed you, so the noise threshold at 0.03 and the max samples 2048, it will take exactly the same amount of time and it looks exactly the same. The seed of the noise is a little bit different, but these two images are exactly the same and they took exactly the same time to render. But when you turn on a very challenging light that the render engine needs to resolve, you get a lot of noise just around that challenging spot of the image. And so if you render this image with 128 samples, the rest of the image will look the same. But the problem is that in the challenging area, it's gonna look like a mess. So traditionally, the way you would solve this problem would be by just increasing the samples for the entire image. But the problem is this part of the image doesn't need the extra samples, only this part of the image. So if you render this exact scene again with the 0.03 threshold and 2048, what you get is exactly this. So the rest of the image looks again exactly the same, but you gave an extra budget for the image to be rendered only where it was needed. And so if you look at the difference, it's enormous. Of course, it took a little bit extra time to render because the Cycles engine had the extra budget of samples to give to this specific image, part of the image. But if I render this image live right now, you can see that the image basically stops rendering. The noise becomes perfectly still once the amount of noise hits the threshold that we specified. So in this case, as you can see in here, the noise doesn't change at all. But if you go close to the very challenging area where the light is, you can see that this is still evolving and is still resolving, but this part of the image is perfectly still, while this keeps rendering. Same things on top of the deer. If I re-render it again, you can see that there is a lot of fireflies and a lot of noise, but as soon as the image, the number of samples hits the amount that we specified, it stops rendering, while the challenging area keeps rendering. So this is basically the perfect trick for this is literally a one-size-fits-all type of solution that actually works in every situation. So literally just copy this setting, 0.03 and max samples to 1048. I also put minimum samples to 16 just because, just as a good measure. But generally speaking, the noise threshold is going to take care of everything, and this is the most important setting that I wanted to share. And keep in mind that if you want less noise, you have to decrease the noise threshold closer and closer to 0. So if you want less noise, you would have to set it to 0.02. If you want even less, 0.01, so on and so forth. But I found that 0.03 is the perfect balance to create a cinematic amount of noise and to keep the render times low as possible, especially for animations. So another setting that I want to share that goes kind of hand in hand with the idea of rendering animations with this method is the seed, the animated seed. So essentially, if you keep this setting off, you will notice a very weird pattern of noise that is essentially static throughout the entire image, even when the camera is moving. So simply just turn this on, it's just way better. So the next setting that you might want to increase based on your scene is the transparent light bounces. So essentially, when you have a lot of alpha textures that are overlapping, not having enough light bounces creates these black glitches. It also works on single objects whenever they're essentially overlapping on top of themselves. So the only way to fix this is to increase the number of transparency, but this is very expensive on the scene, so try to keep it as low as possible, which is one of the reasons why I never use alpha textures in my nature assets, except for trees sometimes, but generally speaking, just try to avoid it as much as possible. Another setting is the volume light bounces. So for volumetric specifically, increasing this does add to the render time, but sometimes it makes the volumes, especially VDBs, look so much better, essentially. But it is very expensive. And next up, the max steps for the volumes. So keep these super low, except when you start to see these black glitches inside of the smoke, and then you can try to increase the max steps a little bit. But this is extremely heavy on the rendering, so just increase this whenever you need it, whenever you actually notice those black boxes inside of the VDBs. Then we have a few settings for water, which is basically just these two checkboxes, reflective and refractive. So you basically only need the second one, otherwise the water is just not gonna show any light from beneath the surface, which is not very good. But you only need to enable this whenever you have an actual surface of water, of translucent water. The second checkbox, I never turn this on because, as you can see, the only thing that it does is that essentially increases the accuracy of the reflected light from the water surface. If I turn it on and off, effect is actually quite subtle, and it only shows up when you have a very extreme situation like this that I'm showing. But when I disable this specific light, this checkbox doesn't add anything to the rendering. It only adds render time, so just keep it off unless the effect is actually very visible, or if you actually rendering something like caustics from a glass shader or something, but in the vast majority of cases you're not gonna need it. The rest of the light bounces I only recommend increasing when you're in an interior environment, and increasing them really obviously contributes to the look of the image, although even 2 light bounces are just enough for photorealism in most situations. So I would still keep these bounces at 2 and then only increase them whenever you have an interior situation like this. Which also brings me to the fast GI approximation checkbox. I never use this because it very rarely makes me save on render time, while it actually costs a lot in terms of accuracy of the lighting, so I never actually found a use case for this. Just leave this off, period. So another very important setting that I've never seen anybody talk about is the indirect light clamping. So as you can see in the same situation I showed you earlier, this is a very intense light that is creating a lot of intense so-called fireflies, which essentially means that the light is bouncing on the surface, but there's not enough rays of light to actually make a very noticeable impact on the surface. So the indirect light essentially allows you to remove the indirect lighting that doesn't have enough resolution, essentially. So this setting needs to tend to 0. So the lower it is, the more apparent it's going to be. So if I put it to something like 0.01, all the indirect lighting is completely gone, but you need to be very careful about this setting because it's gonna take away a lot from your indirect light bounces. So use this sparingly, but it can definitely help a lot in a situation like this where the light on its own is creating all these glitches, all these fireflies. So if you put it something very low, it will help the rendering. So if you use this setting on top of the noise threshold, you're actually going to be able to render very challenging situations. For example, this other render that I made a while ago, it's extremely intense on the light bounces, and it was extremely noisy, specifically because this light situation is very complex. There are volumetrics, there are VDBs, there are point lights that create all these God rays, and without these settings that I just showed you, the noise threshold and the indirect light clamping, this scene would have been a complete mess to render, but it came out perfectly. So definitely use those 2 sliders and experiment based on your scene. A couple more tips for the viewport performance: just disable both noise threshold and denoiser in the viewport. I never turn this on for 2 reasons. The first, the noise threshold just eats up performance. It takes just half a second more for the scene to update, even though it doesn't contribute that much to the overall look of the lighting. I can evaluate the scene just as fine without it, so just leave that off for performance reason. The second one, that the noise can be useful sometimes, but in most situations, especially something as challenging as the one that I'm showing you right now, it's better to leave this off because it creates way too many glitches, and I cannot art direct the scene with such an annoying artifact. So I just leave this off, and this is much better to evaluate, in my opinion. Also, when it comes to denoising, I never denoise my renders. You can do that in 2 ways: from the denoise settings in the render settings, or from the compositor by using some extra channels, but don't do it. And the reason for that is it's not temporally accurate, and what that means is that frame by frame it gets denoised without any knowledge of how the animation is progressing over time, which creates essentially this unbearable artifacts, and it's much better to not have the denoiser on, but having this cinematic level of noise, which is actually very common in cinema cameras. But yeah, I guess that's up to your preference, but I never ever denoise my animations for these specific reasons. These glitches are just too ugly and they are very recognizable. Whenever I see an animation with this artifact, I know that it was rendered in Blender with the denoiser. So I guess it's up to you, but I prefer the cinematic noise. So the problem with the original Blender settings is that they work on every situation, but they are overkill, meaning that you're using resources that you might not need on the specific scene you're working on. So the better workflow is to start from this lower setting and only increase them when you actually notice a difference. Lastly, I wanted to debunk one of the biggest lies in rendering, which would be the high poly geometry takes longer to render. And it's actually not the case at all. The only thing that increases render time is the situation where the light has to bounce in very particular ways. So for example, I rendered this scene 2 times. One time with the low poly deer of about 30,000 faces. Another time I re-subdivided it like 4 times, and it's like 20 million triangles. And it took the exact same amount of time to render. You can see that this subdivided deer looks a little bit different, but the only thing that increased render time was not the amount of geometry in the scene, it was the complexity of the lighting. So for example, the low poly deer with a complex light to calculate took 33 seconds, and the high poly deer just took 10 seconds with simpler lighting to calculate. So yeah, there you go. I just wanted to add that in because I see so much misinformation about this topic. So yeah, I think that just about wraps it up. I have a lot more tutorials incoming, especially for my compositing. I'd love to share how I manipulate my images after the rendering, which make them look a little bit better than the original 3D scene. I would also like to share my default Blender files, so you can look forward to that, and that's it.